Look at this real scenario. You got this airplane, and its axis would be somewhere in the center, but you've got this force vector here. It is not connected to the origin. The origin of the axis in the center of this aircraft, but this is outside, and I want to know the forces acting on this column. So this is basically an example that. Okay. Basically, this is what we're going to do. We've got a vector outside. We are going to link the vectors to the origin, and then it will be easy to find the components of the vector. So let's have a look here. Okay. Well, it says here, a position vector is defined as a fixed vector that locates a point in space relative to another. I've got a vector here. That's my vector. Okay, sorry, this one. That's my vector. And it's directed, it is directed here. A and B, I've got my A here and B here. I've got 2 points. Let the coordinates of A be x, y, z as shown here, and the coordinates of B is given here. And these coordinates are with respect the 2 points and relate it to the origin. Here I've got my point A and its coordinate from O. I've got point B and its coordinate from O. Okay. Okay, sorry. So once you got your coordinates, the 2 coordinates of your vector, rest is easy. All you have to do is to subtract this from this. So xb minus xa will give you, it's difficult to visualize, xx, no, let's do z for me to explain. So so we've got zb and za. So zb minus za will give me this distance of the vector, because it's the zb minus za is the difference of the 2 heights in the z-axis. So that gives me the z component of my vector. In the same way, when I do xb minus xa, it gives me the x distance of the vector. Is that clear? Similarly, just like if I had the axis and I had a vector here in 2D, then if I subtract, hold on, it's difficult to write here. Just give me a minute. If I've got a vector and axis, and I've got a vector here, then my x2 and x1. So I will do x2 minus x1. This gives me this distance. Is that right? In a very same vector r, which is directed from A to B, which means then I do B minus A. If I want the vector r BA, so if I want vector r BA, then my vector is this, is from from A to B. Is that clear? That's given here. Do you get your position vector out? Okay, it's not a unit vector, it's a position vector, position distance. Okay, so as it says here, remember this. Please note that B is the ending point and A is the starting point. So always subtract the tail coordinates from the tip. So our AB means B minus A. Our BA means, so okay, I've got time, so let me finish this one also. Okay, let's look at another thing. So you know a position vector, a vector in space. All you need to know is you get your origin coordinate somewhere, and then you relate the endpoints of that vector to the coordinate, to a coordinate origin. And then to get that specific vector is just like RAB, where you subtract B minus A. Is that clear? No, if you got another vector here, that's what you're saying. Yeah, so it's simple. You got this point, and then you got this vector here. So this is like CD, then this is O, so OC, and then you got OD. That's what I'm going to show you now, how we're going to get this. But you get the coordinate of C, you get the coordinate of D, and you do exactly the same.
But if you have two vectors connected to each other, tail of the second vector is connected to the head of the first, to with some angle in between.
But see, what you're saying is that you got something like this here.
Yes. So we have to only calculate the position vector of the resultant or both. So to get the resultant of both these vectors.
Hold on. Look, if you got a scenario like this, can you get this vector out?
Yes, sir. If we have both the coordinates.
You got the coordinates.
Yes.
So you will have the coordinate of this point also.
Yes.
Sorry. This point, I'll call it D. You will have the coordinate of D.
Yes.
You can get your R out.
Yes.
Because it's like O, like RA and RB.
Yes,
so you got RB, and you can also get RD. So you can get the components of this vector also. So you got two vectors, so you add them up. Is that clear?
So what about if we take the resultant of from A to D and then calculate
Sorry,
the position
from
vector for that vector?
From A to D.
From A to D, not from origin. A to
From A to D.
Yes, sir.
That is the sum of the two vectors.
So if you take the position vector from A to D, would that be same? But
Yes. But the thing is, to get the position vector, you have to use the same approach. You will not be able to get the coordinates. Okay. Okay, so let's look at this now. This is also important. It says that if a force is directed along a line, then we can represent the force vector in Cartesian coordinate by using a unit vector and the force magnitude. So what it's saying basically, if I've got a vector here, okay, and this is basically, this is a rope, okay? It's a rope somewhere connected to a wall. It's a rope, okay? And I want to know up till here the vector of that rope. Okay, so basically it's basically the position on that rope with respect to the origin. So basically, let us say this is 10 meters long. I've made a point somewhere here, and I want to know the position of this point here, point A. I want to know the position of point A. Okay, let me explain again. I've got a rope. Can you see that? It's very difficult to. Give me a second. Let me change the color and come on. Okay, so I've got an axis here. Oh, I can use the same one top here. Yes, I've got, just to make life easy, I've got axis here. Okay, and this is a rope, and that's a point B here. It's already given B here. That's a point B. So I want position vector AB. Okay, A is on the origin here, and B is a point on the rope. I want the vector AB, so it's directed from A to B. Okay, so the position vector of AB will be UAB. That is the position vector. Now, on that same rope, I am applying a force F. And I want the position vector of this force. The force is again being applied from the origin. So what will be the unit vector of this force? UAB is the same thing. That's what is explaining here. Okay. So what it says here is that if a force is directed along a line, then we can represent the force vector Cartesian coordinate by using a unit vector and the force magnitude. So unit vector we'll get from the position. From the position of the vector, we can get a unit vector. And that same unit vector is then applied to the force because the unit vector is the same. Okay, position vector is the position, location. Okay, and force vector is a force. So, how to do that? Find the position vector RAB along 2 points on the line. So, RAB, I've got a line here. Let me make sure the concepts are clear. I've got point AB, the position vector of AB. Okay, I've got another point C here. I've okay, so if I need the position vector and I have got all those coordinates, I've got all those coordinates A, B, C, D. I can pick any two, A and C, to get the position vector out, the unit vector out. Find the position vector AB along 2 points on the line. Okay, on this line you find the position vector, because once you the position vector, sorry, let me explain again. The position vector, that is AB. So position vector AB and position vector AC, is that same?
No, sir.
Yes, no, because it's different. Unit vector is same. Position vector is not same. Position vector, remember, is the distance, position of that vector, the starting point and the end point. So don't get confused between unit vector and position vector. Okay. Now the position vector A, B, and AC, they are different, but they both have got same unit vector. Okay. So therefore, what it says here, you need to find along any 2 points on that line, you find a position vector. And from that position vector, you can find the unit vector. Okay. So find the position vector RAB along 2 points on that line. Find the unit vector describing the line direction. That's, you know this already. And then multiply the unit vector by the magnitude. So basically what it's saying that you find the unit vector of the position vector, and then that same unit vector can be used for the force vector. So if you are given, like in this scenario, if you are given the force and you have to find the magnitude, if you're given the force and you want to find the components, x, y, z component of that force, you need the unit vector. F is the magnitude. You need to multiply it with the unit vector. You can get the unit vector from the position vector, because the unit vector of the position vector and the force vector will be the same. Is that clear to everyone? Okay, don't get confused between position vector and unit vector. Position vector is the position of that vector, whereas the unit vector is just the direction.